Yeah, yesterday what we discussed, guys, we discussed about the service and the, so how many types of services are? Three types of services.
Three
So what are
services.
those? Cluster port, node port, and the load
Node port,
balancer.
load balancer.
Yeah. So yesterday we discussed about the cluster IP and the node port, right? Today we will discuss about the load balancer. Today we'll discuss about the load balancer, guys. Okay. I'm sharing my screen to you guys. Please let me know once you're able to see my screen. Notepad. So if you guys are okay with, so we'll take the classes on tomorrow also, guys. Okay, because of from Tuesday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So there is no classes. Okay. So tomorrow also I will take tomorrow and day after tomorrow also, Monday also continuously. Okay, guys.
Okay, sir.
Yep.
Okay.
Yeah. So we discussed about the yesterday. We discussed about the cluster IP and node port, right, guys? So cluster IP and node port. How to check the services, guys? Service. How to check the service? How to check the service? So which service is enabled in that pod? Guys, which?
kubectl, but it will show on, sir.
What is that? kubectl.
kubectl pod, it will show on, sir, all the information pod if you type
kubectl. Get
pod.
pod. kubectl
Info
get pod
service.
means, so it will get the pods information only, right? So I want a service information. What is the command? kubectl get svc. kubectl get pod. kubectl get
Node.
yes, get nodes, get pods, get pods, get nodes, get svc. Okay. Yeah. So yesterday we discussed about the where is that, guys? Yeah. So yesterday we discussed about the cluster IP and the cluster IP and guys. So what is that? Simple pod,
Node pod.
simple SVC, pod SVC, node port. So here, so instead of SVC, instead of node port, so we can give the load balancer. So we can give the load balancer, load balancer, right? So what is the other service name? So we know the node port, how node port is working, how cluster IP is working, but we didn't see the how it working on the load balancer. So where you need to change that, so you need to change the load balancer here. You need to change the load balancer. So I'm creating a one deployment file. I'm creating a one file. So which includes the pod manifest file and the service manifest file. So pod manifest file and a service manifest file. Guys, now you understood how you are creating your pod? You are creating your pod by using the pod manifest file, and I want to enable the port. I want to enable the outside of the. I want to expose this pod outside of the network. What are the services, guys? So if you want to expose the pod on outside, so we need a
Node port.
node port or the load
Load
balancer.
balancer.
Node port or the load balancer. Here I am changing it to load balancer. What is that, guys? Load balancer. Load balancer. So node port means so we will get the only only expose this pod, something like in this manifest file having the something like a 5 pods. So 5 pods, I want to expose these 5 pods through load balancer. Through load balancer, you can use the load balancer, guys. So we can discuss this now. We can execute this. Mm, so this is the one, right? I want to connect this server. You can use the public IP address. Yeah, public DNS. I'm taking the public DNS. Putty. Yep. Appearance change. Bold 18. Then auth credentials. Browse. EKS 21 batch. Then open. So what is the username, guys? What is the username?
Ubuntu.
Why Ubuntu? We launched the which EC2 instance?
EKS
Ubuntu EC2 instance. So we launched the Ubuntu EC2 instances. So before we launched the Amazon Linux to EC2 instance that time. So what is the username, guys?
EC2 user.
EC2
EC2 user.
hyphen. Yes, it
Mm.
EC2 hyphen user. Very good. So very good. kubectl, guys, don't forget these commands. kubectl get pods.
But kubectl get node.
kubectl get nodes. kubectl get svc. Yeah, why pod is not running? Pod deleted, huh? Okay. So how you can delete everything, guys? You can delete everything by using the kubectl delete all hyphen all. It will delete everything, guys. Pod and svc. Okay. Yeah. So I want to create the load balancer manifest file. So load balancer pod svc.aml. So what is that, guys? I'm creating a load balancer svc. I'm creating a load balancer svc. So this is the load balancer svc. So what is the main manifest file? So what are the main components, guys? API version, kind, metadata, spec. Okay. API version kind. So what is the kind? Yeah, I want to create a pod. What is the kind? I want to create a service. So why service? I want to expose my pod. I want to expose this pod to the outside of the network. So for that reason, we need a service port, service manifest file. So how you can create the pod? You can create the pod by using the pod manifest file. So in the specification, you will provide the containers, right? In the pod, so how many containers will run? So in the pod, we can run the multiple containers or we can run the only one container. Yaka, what is the best suitable, guys? So only the yeah, every pod we can run only one container. We can run only one container, guys. Now it is a so what is my so what is my service type, guys? My service type is load balancer. Let's check WQ. So now let's check, guys, any load balancer is created or not. You can check the load balancers. Yeah. So is there any load balancer created, guys? Nothing, right? So let's
No,
check.
sir.
So I want to apply my so I want to run my that load balancer manifest file. How you can kubectl apply -f the manifest file. So the manifest file kubectl apply -f. So load balancer, right? Pod is created and service is created. Let's check kubectl get pod get pods. Yeah, pod is created. I want the whole details. I want all the details about the where it is running. So 53.181 and 179. So how you can check the SVC, guys? kubectl get SVC. Yeah, you see load balancer is created. So it's created the load balancer. I'm accessing the site through the load balancer. Let's check it. Yeah. So what is the port? 31736. 31736. http:// Yeah, you see guys, one load balancer is created, right? Three one 31736. Yeah, guys, understood. So through the load balancer also we can able to. So this is a not this is I think this is a we forgot guys. Lab 6. Yeah. Yeah, guys, now you understood. So through the load balancer also, so we can. So for example, so how many containers are running? Something like only one pod is running. So only one container is running. The one container we deployed our application. So are you able to see our application or not, guys?
Yes, sir.
Yes, right. Now you understood the what is the service, what is the pod, right?
Yes,
So
sir.
what is the service under? So what is the a pod? So 1 second, I will upload this one also, guys. So what this is? So this is a pod svc yaml file. So now I am creating a other file, call it as a what is the name of the file, guys? Load balancer svc.yaml. Load balancer svc.yaml. Yes, now I want to cat or vi vi load balancer.yaml. Guys, now you understood, right? So what is svc? Why svc? So we need to expose our pods. You need to expose our pod outside of the network. So we can use the service manifest file. So we can use the service manifest file to expose our pods outside of the network. Expose our pods outside of the network. Yeah. Commit the changes. Yeah. Load balancer pod svc.yaml. Guys, I uploaded all the. So while executing, right, while you writing the pod manifest files are a service manifest files. So directly you can write it, guys. You cannot copy, you can write it and try it. So firstly, the first time you will get the errors. So again, you can watch this. You can see the AML file, and let's delete the errors. Let's delete the errors. Then you will execute, guys. Okay. Yeah. Now you understood. You guys are understood about the. So now you guys are understood about the service manifest file, the lower cluster IP, node port IP, and the load balancer, right? So what is the working procedure? So what is the working procedure, guys? So what is the working procedure? Guys, tell me. So what we discussed? So what we discussed as of now, guys? Write a pod aml fast file, right? You know the how to write a pod aml. Write a pod manifest aml file. Write a manifest aml. What is the second one, guys? The second one is create a pod using kubectl apply command, right, guys? Create a pod using kubectl apply command. So what is the third one, guys? Third one is check pod details. How to check the pod details, guys? kubectl get a pod. So I want to see the logs. So pod logs. How you can check the pod logs? So you can check the pod log kubectl get pod logs, right? Pod logs also. Pod logs, and in which worker node, in which worker node the pod is running. The pod is running, right? So in which worker node, we have a two worker node. So we don't know. So if you run the kubectl apply command, so it will check the API server, scheduler, etcd, other control servers, and the kubelet, right? Kubelet, it's an agent for the communication between the worker node and the API worker node and the master node. So it will check it. Oh, so in this server there is a space. So then again it will talk to the Docker container and runtime container, and it will create the container. It will create the pod on that worker node. Right, guys? So next, write a how to write a guys. What is it? How to write a service manifest
AML
aml.
file.
AML file. How to write a service manifest AML file. So then fifth one is check the service to expose the pod, if the pods are exposed or not. How to check or create service to expose pods, right? So the sixth one. So check service details. How you can check the service detail, guys? kubectl get svc and node port number. So assigned by Kubernetes. What is the node port number, guys? So 30,000 to
32,
30,000, 32.
370 something.
Yes, yes. So 370, I will tell you guys. Okay. Yeah. So that thing. So second one is enable node port number. Enable node port number in the guys. Enable node port number in the worker
No,
worker node security group. So we need to enable, right? Otherwise you cannot see that, we cannot see it in the browser, right? So I exposed everything, all. I said the security group, all guys. Access application using the worker node. Access application using the worker node IP. Which IP, guys? Public IP. Okay. So this is the working procedure for the pod and the service. This is the working service for the pod and service. Right. So cluster IP. When we create the pods, every pod will get the unique IP address. So when we create the pods, so every pod will get the unique IP address. So when we access pod inside the cluster using its IP address nodes, so we already discussed it, right? Yeah, we already discussed these things. So these are the cluster setup, guys. If you want, you can see it here. Yeah, so it is recommended to run the commands in the master node. No. So we can access the master node from the remote machine using the kubectl command. So because of if you run the commands in the master node, definitely if you delete something, right, everything will crash. That's the reason we created a remote mission. So we created a remote mission and so we are running the commands from the remote mission. Now you understood, guys? So we created a three instances. So we created a three instances. So this is the remote machine and EKS is the master node. These are the worker nodes. So EKS is the master node. These are the two worker nodes, right? Yeah. EKS you already knows, right? The Kubernetes architecture. You already know the Kubernetes architecture. Kubernetes controller, kube control manager, kube API server, kube scheduler, etcd, kubelet to kube proxy, kubelet to kube proxy, kubelet to kube proxy, container runtime, container runtime, container runtime. So these all are the applications, right? These all are the our application. These are the worker nodes. Worker nodes will apply the applications. So launch a new visitor instance for the kubectl command. We already launched it, right? So Kubernetes core components, Kubernetes resources, objects, container, pod, namespace, service, deployment. We know container, we know pod, we know service. So we need to know the namespace and the deployment, right? So namespace and the deployment. Service cluster IP, case service concept, cluster IP commands. Yeah, we already know node port. Yeah, what is the range, guys? So the notepad range is 30,000 to 32,767. So what is that, guys? 32,767. Yeah. So this is the range of the node port. Yeah, so node port service, you already know. Node port service Kubernetes will assign a random port number. We can access our service outside the cluster using any cluster, mission IP, mission public IP with the node port. Enable a node port in the security group. So URL access. So we already access it, right? So load balancer. It is one type of the Kubernetes service. It is used to expose our pods outside the cluster using the load balancer. So when we use the load balancer as a service type, then the one load balancer will be created in AWS cloud. So using that load balancer URL, we can access our application. Load balancer will distribute the traffic to the multiple worker nodes in the round robin fashion. So round robin fashion. Guys, understood, right? Yeah, you see. So here we can provide the load balancer. So pod life cycle. You already know the pod life cycle, guys. So Pod is a smallest building block that we can run in the Kubernetes cluster. We are using the kubectl to send request to the control plane to create a prod. API server will receive our request and will store request to details in the etcd. Scheduler will find the unscheduled pods. It will schedule in the worker nodes. Node agent kubelet will see the pod schedule and it will fire the Docker engine. So Docker engine will run our containers. Pods are ephemeral, short-lived objects. So manually created pods is recommended, guys. So this is the most important topics. So why Kubernetes? Kubernetes is managing everything. So what manages? So they manages the auto healing. What is that, guys? Auto healing, auto
Okay.
and auto healing and the auto scaling. So auto healing and the auto healing. Now I am now I am deleting the pods, guys. Is it auto healing means it automatically create the pods. But so if I delete the pods, yeah, I'm deleting the pods. Yeah, delete it, right? So auto healing capacity. What Kubernetes is providing? Kubernetes is providing the K8s. K8s provides auto healing. Auto healing means if the pod is crashes. So for example, if the pod is crashes or if the pod is deleted, automatically create the another pod. If the pod is created or not, let's check, guys. kubectl get pods. You see, is the pod is created? No, it's not created. How the pods created? How if the pod is crashes or deleted, how it will be created? It will create by using the replication controller and replica set. I will show you guys. So we'll create a replica set and replica. So manually created pod is not recommended. So manually created pod is not recommended. In the above scenario, we have to create a pod manually. It is not recommended because of Kubernetes having the auto healing capacity. If we create the pod, then Kubernetes will not provide a high availability. So let's test it by deleting our pods. kubectl delete pod name. So note once pod got deleted, Kubernetes not creating the another pod and application went down, not accessible. So if we want to achieve high availability, then we should not create the pods manually. So if you want achieve high availability, then we should not create the pods manually. So we need to use the Kubernetes components to create the pods, then Kubernetes will provide a high availability. So high availability means always our application should be accessible. So always our application should be accessible. Now are you able to access your application? Now are you
No,
able to
sir.
access your application? So because of the pod is deleted. The pod is deleted. So you can achieve these by using the Kubernetes components. What is it? Kubernetes components. What are those? Replication controller, replication set, daemon set, deployment, stateful sets. So what are the Kubernetes components, guys? Replication. So
Controller.
replication controller, replication set, daemon set, deployment, stateful. So for example, guys, so we will set the, so how we can replica set. So replica set equal to, so for example, replica set 3. So if the pod is deleted, it automatically, it is verifying how many replicas, 3 replicas we need. Or how many, for example, I said the 1 replica. So it will check if the pod is running or not. If the pod is deleted, automatically the another pod will created. So that is the beauty of the Kubernetes. How you can achieve? You can achieve by using the replica set. Guys, this is most important topic. Okay. So what is that, guys? Replica set will validate the pods, and if the pod is crashes, it automatically create the another pod. So every time how many pods will create, guys? How many pods will running? Only one pod will running one pod will running. For example, 3. So how many pods running every time, guys? So it will check, and 3 pods will running at a time. So based on the replica set count. So how many pods are running? So how many pods are running at a time? The 3 pods, every time the 3 pods will be running. If 2 pods are deleted, it automatically creates the another 2 pods. So why we are not using the cluster IP to expose our pods? So pod IP. So pod IP will if the pod is deleted, right? It automatically create another pod and it will change the IP addresses. So that's the reason we are not using the pod IP addresses to expose our to see the application on the outside, because of we are creating the cluster IP for the for the node. Okay. Yeah. So what is that? A replication controller, replication set, daemon set, deployment, stateful set. So what is a replication controller? So what is a replication controller? What is a replication controller, guys? So replication controller. So replication controller. So replication controller. So it is one of the key features in the Kubernetes. So it is responsible to manage pods lifecycle. It will be make sure given number of pod replicas are running at any point of time. So it will make sure given number of pod replicas are running at any point of time. So if any pod got crashes, deleted, dead, then replication controller will replace it. So if any pod got crashed, deleted, or dead, then the replication controller will replace it. So replication controller is providing facility to create a multiple pods, and it will make sure pods always exist to run our application. Using the replication controller, we can achieve high availability. So replication controller and pods are associated with the labels and selectors. So the replication controller pods are associated with the labels and selector. The service also associated with the labels and selectors. Labels and selectors. Replication control. It is a Kubernetes component which is used to create the pods. It will make sure always given number of pods running our application. So it will take care of the pod lifecycle. When pod is crashed, deleted, or uh, damaged, deleted, then replication controller will create the new pod. So we can scale up and scale down the pod count using the replication controller. So given the replication controller, scale down, scaled up manually, kubectl delete all hyphen all, kubectl apply hyphen f, rc.ml. rc means replication controller. So once we create the replication controller, right, we can check the pod where the pod is in the work, which worker node the pod is running. Kubectl get svc, kubectl get rc. rc means so give kubectl get pods means pods, kubectl get nodes means nodes, so kubectl get svc means svc, kubectl get rc means replication controller. So replication controller. If you want to scale up and scale down the replicas, we can use the these commands. Okay, manifest file creation. So this is the pod manifest file. This is the node port service. So manifest file. We already knows, right? So that service, that is the service manifest file. So replication controller AML. Something like yeah. So we have already created in the replication controller, guys. Where I already created. So this is the my Tomcat SVC. Created somewhere, guys. One second. Yeah, I created here, guys. Namespace svc.aml. So this is the namespace. So this is the namespace, right? Next, I want to see the namespace svc replica set replication controller. Yes, guys. So this is the replication controller YAML file. So in the replication controller, yeah, I will show it to you. Copy. So what is that, guys? The replication controller. So API version v1, the kind. So kind before it is a pod, now it is a replication controller. So because of, so we need a replica sets, right? Replicas. How many replicas we need to access? 3 replicas. So that's the reason we are using the replication controller. So API version v1 kind replication controller metadata name equal to nginx web app rc nginx web app rc spec. So replicas 3 selector app nginx web app. So what is the replicas? The selector app is nginx web app template. So metadata of the nginx labels spec container. So what is the container? The container is web app nginx, the port. So then, so I want to expose this, or if I want to expose this port board in the outside. Yeah, so by using the node port, the selector is web app nginx web app. So target port equal to 80. So the container port equal to 80. So let's try this, guys. Let's try this. Yeah, so replication controller. So if we use the replication controller, shit, guys, duplication, Ubuntu. Yeah, I'm creating a rc.aml. So replication controller.aml. So what is that? API version kind equal to replication controller metadata. What is the name of the metadata? nginx web app rc. So spec replicas equal to 3 here. So what is that? Replicas and selectors and labels, guys. Based on this only. So selector. What is the selector? App nginx. So we can you can use the selector. So I want to expose this pod. Which pod? Nginx web app pod. So I want to expose this pod in the node port, and I want to create a replication controller. So replication controller means it will create the replicas. So it will create the replicas. Okay. So now, so let's check kubectl get pods, right? Get pods. So no pods are created. Now kubectl apply -f. So what is that, guys? Name rc.aml. rc.aml. It will create the replication controllers. Error parsing rc.aml error converting aml to JSON aml line to mapping values are not allowed to this contest. Let's check, guys. So initially, so this is the API version replication controller metadata name nginx web app rc spec replicas 3 selector app nginx template metadata name labels metadata template. In the template, so there is a metadata for the nginx web app pod nginx web app rc. So this is for the replication controller. So this is template of metadata is this one, labels equal to app, and spec containers name nginx app, image nginx, ports container ports. Okay, this is API version v1 kind service metadata name nginx svc, name here nginx svc rc spec Maybe the issue with here, guys. Metadata. So what is that, guys? Name. Yeah, this is the issue. Name, metadata name, right? T and spec is the metadata type node portal. Let me check the yesterday's ones, guys, because of here is the issue.
Sir, maybe NGINX web app is the issue, sir.
Why?
The
The selector.
same yesterday also. App is once you check from your Hare Krishna, you selected yesterday, sir. That one.
Yes. Selector app. Yeah, let's check that one. Yeah, API version v1 kind service metadata n name a spec type. So here is the issue. Type will in the yes, then it will be the selector same selector. App will be in the ls. Then ports from the selector. Yes, PURTS ports hyphen port. Yes, target port 8080. Okay, let's check. Error parsing rc.ml, error converting YAML to JSON YAML, line number 2. Mapping values are not allowed within this context. Line number 2. Replication controller only, right? A replication controller. Yeah, replication controller only, right? Unix container. Replicas API version replication controller. So the spell is replication controller. Same, right? API version, kind replication version, name, metadata, name, nginx web app rc, spec, replicas, replicas 3, then selector, then app template metadata, name, labels, app, spec containers, spec from the metadata, containers, name, Java web application container, image nginx, ports, container ports. Yeah, maybe the issue also here. Ports from here, right? P container port, container port 80. Yes, 8080. This API. 1 second, guys. Yeah, API version v1 kind service metadata name spec type, selector, app, ports, target port. Yes, this looks good, right? Now let's check, guys. Mapping values are not allowed in this content. kubectl apply if rc.ml. kubectl delete all all. Yeah, kubectl apply -f rc.ml. rc.ml only, right? We created rc.ml. So what is the issue, guys? So we have a issue with nginx, right? nginx. Let's take this example, guys. What is it? Cat podsvc.ml. So I am taking this reference again. So what is this, guys? I'm comparing API version v1 kind equal to. So I'm giving this replication controller. Yeah, time over. So replication controller metadata spec templates containers. I'm taking from here. Metadata name my tomcat 9, my tomcat cat 9 template, my tomcat 9, my tomcat 9 container, my tomcat 9 and the image from I want to get it from here. You want to get this image from the here ports container port 80. Okay, so where I want to remove this from the metadata. So metadata spec replicas selector. Yeah, so here also my tomcat photo target port 8080. Yeah, let's try this, guys. Copy varc.m. API version v1 kind replication controller metadata replica sets selector metadata label spec containers ports target port. So here also ports from here. Containers name image ports, but I want to connect these ports from R. Yes, R ports container 80. Yes, guys, let's try this. Yeah, you see, there is a issue with the nginx, guys. So there is a issue with the nginx. That's the reason it is not creating. Yeah, kubectl. Now let's check kubectl get pods. Okay, how many pods are running, guys? Now, now how many
3.
pods are running? 3 pods are running. What is the replica set, guys? The replica set is, so what is the
3.
replica set? 3. Okay, so kubectl get svc, get svc. Yeah, the node port number, guys. So now I am trying to delete the pods. Now I want to try to delete the pods. Okay, what is the pod, guys? kubectl delete rc. What is that, guys? Delete rc. The
Dot
name
YML.
is no. So the delete pod, delete rc replication controller. For example, this one. Kubectl get rc. Kubectl get rc. rc is nothing but a replication controller. So you see, guys, replication controller, 3 controllers. So I want to delete the pod, guys. Kubectl delete pod name. What is the pod, guys? So this is the pod name. So before that -o void. So you will check the, sorry, get yeah. So this is running on the node here. So this pod is running on one node. These 2 pods are running on these 2 nodes. So what are those? So kubectl delete pod name. So one pod is deleted. Now let's check how many pods are running. Kubectl get pods, -o void, get pods -o void. But we deleted the one pod. Again, it is running the 3 pods. You see, guys. So these 2 pods are running from how many days? How many seconds?
2 minutes.
The age
2
of
minutes.
2 minutes and 33 seconds. But this pod is running from
14 seconds.
14 seconds. This pod is running from the 14 seconds. So if you set the replica set, if you delete, it automatically creates by Kubernetes. It will check how many replicas are available, right? How many replicas are available? So 3 replicas. If you delete 3, it automatically create again 3. So what is what is this this feature? This is a auto. What is this, guys? Auto
Auto
healing.
heat.
So if the pods are deleted, so auto healing. So if the pods are deleted, crashed, or something like a dead, it automatically so verify the replica sets. So and we need to set the, we need to create the another parts also. A deleted pod automatically creates. Now you understood replication controller. So replication
Okay.
controller is most important. So replication controller, replica set. Replica set is the advance for the replication controller, guys. Okay. So we'll show you tomorrow. vi rc.aml file. Yeah, guys. I'm creating this file. I'm copying and pasting it in the. So this is the replication controller, right? So I will create a Kubernetes. Add a file, create a file, replication controller.aml. replication controller.aml. So there is a issue with the nginx, guys. That's the reason. So nginx is not loading, so it is getting the error. Yeah, I created the replication controller. So guys, now you got it. So I said the replication, the replicas is the most important. Replicas, so it automatically, if the three pods are deleted, it automatically create the another three pods, right? It automatically creates the another three pods. Okay, so we'll continue from tomorrow, guys. We have a class on tomorrow also. Okay guys, are you available?
Okay.
Saturday, right? Pavan, you are not available from tomorrow, na?
No, Monday.
Monday?
Sunday I think.
Sunday you are not joining. So tomorrow you will join, right?
Tomorrow also I think.
Sorry?
Tomorrow also I think.
I didn't
Sunday
get
morning.
your voice. Your voice is breaking. So are you joining? You will join tomorrow or not?
I will try.
You will try, yeah. Okay.
I,
Guys, we'll teach, we'll take the class on Monday because of replication controller and replica set is most important, guys. Okay. So no worries.
Okay.
So we'll start Monday. So these are the most important topics, Pavan. You need to be there in the call.
okay.
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 Yeah. Thank you.